Okay, here we are, Chapter 5, 5.3, and we're looking at solving radical equations. This time these have two roots. Now, you'll notice that the two roots in this example, one of the root is a binomial, one of them is just a single term monomial. Our goal is going to be to rearrange the equation to get the binomial by itself on one side of the equation. Then when we square it, we're going to get rid of the big root first. So we'll go ahead and do that. 7 plus root 3x is root 5x plus 4 plus 5. Subtract 5 from both sides, and it leaves us with 2 plus. Back this up. 2 plus root 3x equals root 5x plus 4. Now we can square both sides. By squaring both sides, on the left side we have to FOIL it. You're going to get 2 times root 3x plus another 2 times root 3x plus root 9x squared. On the right side, this will clean up nicely to be 5x plus 4. Now when I clean this up on the left side, the middle terms can add together, so you're going to get 4 plus 4 root 3x plus 3x equals 5x plus 4. Now, we still have a root 3x here in our equation. We want to get that by itself. So what we're going to do is we're going to subtract 4 from both sides, and then we're going to subtract 3x from both sides to isolate that root 3x. This leaves us with 4 root 3x equals 2. Now, I could divide both sides by 4 at this point to get to 3x by itself, or I can just square both sides and keep whole numbers here. So that's what I'm going to do. I'm going to square both sides, and that'll give me 16 root 9x squared. The root 9x squared is simply going to become 3x equals, square the other side, 4x squared. 16 times 3 is 48x equals 4x squared. And if I subtract 48x from both sides, I'll have a quadratic equation that says, I see, divided both sides by 4, then subtract 12x from both sides, and I get 0 is equal to x squared minus 12x. Well, when you see something like this, you have to consider that the last term is 0. I can factor an x out of both of those two terms that are left, so I'm going to get x times x minus 12. This is something you have to learn to recognize in questions like this. They look hard to do, but they're quite easy. Now x is equal to 0 is going to be the solution for the first one. X equals 12 is the solution for the second. Now remember, we have to verify those before we can say that they are the roots. So we need to plug them both in to our equation. When x is equal to 0, we're going to have 7 plus the root of 3 times 0. 3 times 0 is 0, equals 5 times 0 plus 4, which is just 0 plus 4 plus 5. Now we got 7 plus root 0, which is 7, equals root 4, which is 2, plus 5, so 7 equals 7, and 0 works. On the other side, we got x equals 12. 7 plus root 3 times 12. 3 times 12 is 36. Has to equal 5 times 12, which is 60, plus 4 is root 64 plus 5. This will become 7 plus 6 equals 8 plus 5. 13 equals 13. So they both verifies. And this equation then will have two roots, 0 and 12.